The smell of rain, otherwise known as petrichor. It's a smell we all love and it's a smell we all know, but how exactly does it work? How exactly can we get that scent? And why does it smell differently in different parts of the world? We're going to explore a little bit how exactly we can get that smell of petrichor, what exactly constitutes it, and why it makes you feel good. Like most people, I'm sure you love that smell of rain right after a nice light drizzle and you're walking outside and it feels like you can just smell the earth around you. But we're going to talk a little bit about how exactly that works. One of the main things we need to understand is aerosols. Aerosols are essentially compounds that have been put into the air. I'm sure you think of like your aerosol can and how that's been pressurized so that you can spray either olive oil or deodorant or perfume. Researchers at MIT actually found out a way in which rain can hit the ground, and essentially the more porous that it is can actually act as a way to develop aerosols. So in this way, we can actually get Earth to be as an aerosol. So picture this, a raindrop falls from the sky, hits a porous surface, and with its speed will actually kick up dirt in such a way with water. So we can get a Earth-like scent, but we're also going to get bacteria and even viruses. And this is going to contribute to the overall smell of petrichor. Another contributing factor of this petrichor smell can also just be the plants around us and the environment that we're in. Is it dusty? Is it dry? These can all lead to a different type of petrichor smell. And so one of the things that we also need to look at is something called terpenes. Now, terpenes are a large subject and overall pretty diverse when it comes to compounds. However, the general rule is that plants and even some insects develop these compounds in order to protect themselves or to give off a particular scent. Now, these scents can be quite strong and repel herbivores and actually attract predators for these herbivores. In a way, they work to protect the plant or insect against harm. If you've ever smelled a lemon or lavender or even a pine cone, then you've smelled limonene, pinene, or even linalool, which these are all terpenes that you've no doubt smelled. And just in the same manner, when rain hits the ground and kicks up all that earth scent, one of the things that gives it its unique scent are these terpenes. And it can help give it maybe a lighter, sweeter scent, or even a mustier scent. Overall, terpenes provide a large spectrum when it comes to the smell of petrichor. This is one of the many reasons why in different places of the world, petrichor actually smells a little bit different. It's not just your usual scent. In fact, maybe in America, in the West, it smells a little bit more like the forest, while compared to a place like Western Australia, which might be a little bit more dry and not have as many plants. So in this case, bacteria and viruses actually might help contribute more to the smell. Now, one of the biggest contributors of petrichor is actually an organic compound that's made by bacteria called geosmin. Now, geosmin is generally produced by bacteria, and it is released when these bacteria die. And so depending on how much of these bacteria are in the area, we can actually get a much more earthy and even musty smell. This is going to lead to a large contributor of what actually petrichor smells like. Interestingly, humans actually have a great detection for geosmin. In fact, we can smell even 5 parts per trillion. So that's pretty small by all standards, and some researchers actually claim that this is probably because of evolution. In fact, our ancestors depended on the rain, so no doubt we've also had to come to that same conclusion. In fact, some researchers claim that the reason that we're so sensitive to geosmin is because our ancestors depended on the rain so much. This makes sense, as our ancestors had to follow the rain and ultimately had to follow lush and green areas in order to grow their crops, in order to feed their herd. So it makes a lot of sense why we've evolved in order to smell petrichor. We've evolved to smell that slight moisture in the air. Now, geosmin is also produced even for fish. So if you've ever had fish, and if you felt like you've been able to taste some sort of musty, earthy taste from them, then no doubt you're tasting geosmin. In fact, it's one of the reasons why we even cook with lemons and other citruses when we're making fish. It's because geosmin breaks down actually pretty rapidly in the presence of an acid. Now, you might have even had geosmin, unfortunately, in a really disgusting way, in your drinking water. If you've ever had water that's either left out or maybe even unfortunately had it from a bad source, like a dirty well, or a contaminated water system, then no doubt you've tasted geosmin. It tastes musty and it tastes very earthy and muddy. And now onto the reason of why we probably love petrichor even beyond evolution. One of the things that rain does as it hits the earth is perform chemical reactions using oxygen and water. One of these reactions happens with ammonia that's commonly found in the ground. This reaction is simple. It is ammonia, NH3, with oxygen to give us nitric oxide and water. So, in the case of nitric oxide, in case you're not aware, it's a signaling molecule in our bodies. In fact, it's one that generally tells us to calm and be relaxed. And so when we smell this petrichor, some of what we're getting is nitric oxide, which I guess makes us a little bit more calm and relaxed about the whole situation. And so with that, we now understand why petrichor works, how it happens, how we can smell it, why it might smell different in different parts of a country or even countries. Overall, it's rain hitting the earth and causing an aerosol mixture of bacteria, viruses, terpenes, geosmin, and even nitric oxide. It's a scent that we all know, and I'm assuming most of us like, and no doubt it probably calms you down. It's something that now we can think a little bit more about how the chemical reactions are going on when we go outside after rain.